Okay, problem 4 is, of course, based on a true story, where I was wandering through a strange forest and found a sign leading to these two places. So, let's see. The sign says 1.3 miles to Goldilocks' grandmother's cottage, 3 miles to the Three Bears house. And knowing nothing else, I had to figure out the minimum and maximum possible distances. So, you may have figured out the ulterior motive here, but the point was to get you thinking about vectors. And so what we're really saying is that, let's say we have a vector going from where I am now to, come on, brushes, there we go, to, and I don't really want that color either. So you'll discover I'm picky about my colors. Okay, let's go with this browny color. Okay, so this is vector R1 leads to Goldilocks' grandmother cottage, or that's the position of Goldilocks' grandmother cottage with respect to us right now. And R2 is the position that leads us, or is the vector that will lead us to the Three Bears house. Okay, now we don't know the directions these guys are pointing in, right? Don't know the directions. We do know the magnitudes, right? We know that the magnitude of R1 is 1.3 miles, and the magnitude of R2 is 3.0 miles. So the question really is asking, what if we had a vector leading from Goldilocks' grandmother's cottage to the Three Bears house, what is the maximum magnitude of that vector, and what's the minimum magnitude of that vector? So what you can do is you can sort of, really the best way to see it, I think, is to go graphically. So here's U in the middle, okay? Now, let's say this red circle here, okay, has a radius of, let's call that radius, that's got a radius of R1, which is the magnitude of this guy, okay? So that's R1. This is using the normal convention where a vector name written as a scalar is taken to mean the magnitude of the vector if nobody says otherwise, okay? And here, this blue circle here, okay, has a radius of R2. And what you can see then is that any point on the blue circle is a possible location for the Three Bears house, right? Because the circle is all the points that are 3 miles away. And any point on the red circle is a possible location for Goldilocks' grandmother's cottage, because those points are all 1.3 miles away. And so what is of all the possible locations that both of these things could be, what's the minimum distance between them and what's the maximum? And I think what you'll see is that the minimum distance would be when they are, right as close as they can be on the circles, right? And the maximum distance would be when, say, this is where Three Bears house is, and Goldilocks' grandmother's cottage is clear on the other side. And so then, it's not hard to figure out that the minimum is going to be the radius of this circle minus the radius of the inner circle, and the maximum is going to be, so that's when you're going from here into here, there's that difference, and then the maximum is when you have to go all the way through the center and go to the far side of the inner circle. So it's going to be R2 plus R1. So what this generalizes to, if we want to sort of take a vector, no, I don't want to learn up. Stupid Windows. All right, so if we want to take this to sort of a generalized point about vectors, then what we can learn from this is that, say we have two vectors, and we have, let's say, vector C equals vector A minus vector B. Okay, and what that means is that if C is the magnitude of vector C, okay, A is the magnitude of vector A, and these are the normal things, okay, and B is the magnitude of vector B, then what you know is that C must be, must be greater than, and I'm writing it as less than sign because I'm going to go this way, but C must be greater than or equal to A minus B. And since we haven't specified whether A or B is longer, really, this should be an absolute value, okay? And C must be less than or equal to the magnitude of A plus B. So to put it in layman's terms, not in layman's terms, but in more practical terms, if you're adding up two vectors, and one of them, or sorry, you're taking the difference between two vectors. One of them has a magnitude of 1.3 and one has a magnitude of 3.0, then your minimum possible for this case is 1.7 miles, and your maximum possible is the sum of the two, which is 4.3 miles. And that's something you can, you could use to you can use to check when you're doing problems like this, because it's a good little quick intuitive check you can do. And see if your answer at least makes sense with this. And if it doesn't, then you have to go back and check something.